We'll talk about Newton's law of cooling. The temperature of an object T in the surrounding air with temperature T sub S, S for surrounding, big T for temperature, will behave according to the formula capital T, that's temperature, of little t, that's time, equals AE to the KT plus T sub S, that's surrounding temperature. T is time, A is the difference between the initial temperature of the object and the surroundings. So when you first, like if you're take a turkey out of the oven and the temperature of the turkey compared to the room it's in, like the kitchen, probably the kitchen, I assume is where you're cooking. Okay, and K is a constant, the continuous rate of cooling of the object. So that's Newton's law of cooling. It's kind of interesting the way it works is that you start off at this temperature and it goes down and it ends up at this temperature, which this is your T sub S. And if you think about it, your power on K is negative. So this portion of it is getting smaller and smaller as time goes on until eventually you get to your room temperature. So how to apply Newton's law of cooling? Set T sub S equal to the y coordinate of the horizontal asymptote, usually ambient temperature. Substitute the given values into the continuous growth formula. T of T equals A plus E to the KT plus T sub S to find the parameters A and K, and substitute in the desired time to find the temperature, or the desired temperature to find the time. A cheesecake is taken out of the oven with an ideal internal temperature of 165 and is placed into a refrigerator at 35 degrees. After 10 minutes, cheesecake is cooled to 150. So we have a data point with 0, it's 165. At 10 minutes, it's 150. If we wait until the cheesecake is cooled to 70 degrees, how long do we have to wait? So we want the time is what for the temperature to equal 70. Okay, so we'll be using this formula. T of little t equals A e to the KT plus, and our T sub S we said was 35 plus 35. Now we know at time equals 0, it's 165. So 165 is A e to the K times 0 plus 35. So 165 is A e to the 0 plus 35. E to the 0 is 1, so 165 is A times 1 plus 35. And we subtract the 35, and that's going to be 130 is equal to A. And that's what they kind of told us in the beginning. It's the difference between the ambient temperature and the temperature that it starts with. So we probably could have started with that. So that T of T is equal to 130 times E to the KT plus 35. Now we have another data point right here, this 150. So that means it's 150 degrees after 10 minutes. So 150 equals 130 E to the K times 10 plus 35. So solving for K, we subtract 35 from both sides. So that's going to be 115, I believe, equals 130 E to the 10K. Then we can divide by the 130 because we're solving for K. So that 115 over 130 equals 10K, equals E to the 10K. So the natural log of 115 over 130 equals the natural log of E to the 10K. Like that essentially cancels. So the natural log of 115 over 130 equals 10K. And then we can divide by 10. So K works out to be approximately, and I hesitate to do an approximation, but it's going to be approximately negative 0.0123. So our formula, T of t, is 130 times E. Oh, I'm trying to save space because I feel like I'm going to run out of, erase please. I feel like I'm going to run out of space here. See if I can adjust my window a little bit. Okay, it's a little better. So T of t is going to be 130 e to the negative 0.0123 times t plus 35. So what is it going to be after 10 minutes? No, when is it going to be 70 degrees is the question. So that means our temperature becomes 70. So 70 equals 130 times e to the negative 0.0123 t plus 35. So we subtract 35 from both sides. So 35 equals 130 e to the negative 0.0123 t. Divide by 130. Scroll this down a little bit. And we'd have 35 over 130 equals e to the negative 0.0123 t. Natural log of 35 over 130 equals natural log of e to the negative 0.0123 t. So we'll take this over to here. We would have negative 0.0123 t equals the natural log of 35 over 130 divided by negative 0.0123 and t would be the natural log of 35 over 130 divided by, so this is the whole thing divided by, negative 0.0123, which is approximately, how long? 106.68 minutes. That's a long time. Wait, essentially 107 minutes to eat the cheesecake. Torturous times. Okay. Fun stuff. You could try something like that with your turkey calculations if you celebrate Thanksgiving.